Okay, so let's go. Let's look at the questions. This is summer 2015. Okay, the first variant, question paper 1-1, question 6. Now, here we go. The line with gradient -2 passing through the point P, 3t, 2t, intersects the x-axis at A and the y-axis at B. I. Find the area of triangle AOB in terms of T. Now the second part says that the line through P perpendicular to AB intersects the x-axis at C. The II says that show that the midpoint of PC lies on the line y is equal to x. Okay, so we're just going to address that problem that was put there. This was the 2015, as the question rightly said, 2015 summer 2015. Question 6, question paper 1-1. Okay, so the question paper 1-1, question 6. This is by courtesy of Cambridge. I think it's on their website. So you'll find the question there. So the questions, all the questions that, like we said, are being reproduced in this section. It's not of our own creation. These are CIE questions that they've administered in the A-level exam over the period. So you can access those questions on the Cambridge website, or maybe when you go to our website, you can find links to that. That can help you get a question. We will just focus on how we can go around it. Okay. All right. So the summer 2015, we just label it S15QP11. Okay. That's question paper 1-1, question 6. Question 6. It says that, like you just saw, I'll just read it for the benefit, just to allow for easy remembrance. The line with gradient -2. So the gradient of the line, they say, is -2. Grad is what? -2, okay? And passing through the point P. It passes through the point P, 3t, 2t, okay? And they are saying that it intersects the x-axis at A. So x-axis A, okay? And y-axis at B. Y-axis B. Guys, hope you understand that. Yes, so that's what we have. Then the first part, we are being told to find the area of the triangle AOB. AOB in terms of T. All right, so that's the problem that we've been asked to resolve. That's the first part of the problem, okay? So we have a line. And this line, we are saying that the gradient of the line is -2. The line goes through the point P. P is 3t, 2t. Those are the points that the line goes through, okay? And we are saying that it also cuts the x-axis at point A. And again, the y-axis, it cuts at point B. We are being asked to find the triangle AOB. You may ask, the O refers to the origin. That is what it means. So x-axis is A, then the origin O, then you go there, B on the y-axis. That gives you the triangle. You're saying that what is the area of this triangle? What do we do? What do we do? Remember, in coordinate geometry, especially for this particular part in your session, you would always have to look at how to find the equation of the line. You first need to find the equation of the line, because remember, the equation of the line is simply the relation that connects all the points, okay? That makes all the points on the line true, right? So if there is anything that has got to do with the points that are found on the line, the relation that's able to connect all those points is the equation of the line. When such questions appear in the exam, always have your mind on the equation of the line. In fact, most coordinate geometry problems, one, for straight line, always has got that test of the equation of the straight line. Always watch out for that. And you know that what we said about the equation of a line is the 1-point formula. The 1-point formula simply knows, like in the regular courses as you've seen, where you have a 1 point, a given point, okay, for that particular line that you want, and also the gradient is known. So when you know the gradient, one of the gradients, like when you know the gradient and you know one of the points, the 1-point formula can just help you to find the equation of the line. Hope you are clear with that. Now let us remember what the 1-point formula is. It says y minus y1 is equal to m into brackets x minus x1. That is what we call the 1-point formula. Okay, so the x1, y1 refers to that one point, and m is the gradient. Y is just a general term, and the x is also the general term, okay? So with a 1-point formula, y minus y1 equal to m into brackets x minus x1. As we spoke about in the introductory part of this thing, it's able to help you to get the equation of the straight line. I hope guys, it's clear. Okay, it's clear. Good. So we are saying that the gradient is minus 2. And it passed through the point P, 3t and 2t. And hence, we can say that we have the 1-point formula. We can use the 1-point formula to find the equation of the line. So what is the equation of the line? Let's do the substitution. Okay, so now just keep your eye here. So we're going to have y minus y1. Remember, we are using this point, 3t, 2t. So this, you should know, it's your x part, and that will be your y, okay? All right, so your y minus y1, you make use of the 2t, equal to m minus 2 into brackets x minus x1, x minus 3t. Hope you're okay with that. All right, so what then do we do? We're going to have y minus 3t equal to minus 2x nege po. So negative 2 times minus 3t is going to give you plus 6t, okay? So try to put the t's together. This is going to give you y equal to minus 2x plus 6t plus 3t, okay? So this is going to give you minus 2x plus 9t. Just take some seconds and just see what you have there. Are we okay? All right. Let's just make a correction. Sorry. I think this is minus 2t, okay? So this portion here should still be minus 2t. So let's keep the 2t there, and let's rectify that. Here gives you 2t, so it should be 8t. All right, so please just correct that in your notes, in what you're writing. Hence, the equation of the line is going to give you y equal to minus 2x plus 8t. That's the equation of the line. Guys, hope you're okay. Great. Now, we are saying that this line cuts the x-axis at point A. And again, it cuts the y-axis at point B. So how do we deal with that? We know that on the x-axis, y is equal to 0. So we pick the equation of the line and try and find the values of a on the x-axis. And at that point on a on the x-axis, we know that y is equal to 0. So let's pick it at a. At a. Watch. At a. So this is the point that we have to get for a. Okay? By implication, at a x-axis, your y is equal to 0. What do we do? Okay, so we're going to have 0 is equal to, not y, because y is 0. 0 is equal to minus 2x plus 8t. Now, when you do that, the algebra, you take that to the right side, you're going to have 2x is equal to 8t, and your x should give you 4t. Okay? All right. So, at A, what do we have? At point A, we can say that at A, our values will be what? We are going to have your A point being 4t, because that's your x, and 0. So that's what you get for A. Okay. Now let's find for the y. So let's find the values of y. What happens to that? What is the coordinates of B on the y-axis? Okay, so we want to find the coordinates of the point B, okay? The coordinates of point B, because we've seen that for the x-axis, your A is going to be 40, 0. And remember, we just kept this part here for your equation of the straight line. Y is equal to minus 2x plus 8t. So on the y-axis, what happens? Your b is on the y-axis, and on the y-axis, x is equal to 0. So what's going to be the value of your b? Your b is going to be y is equal to, on the y-axis, x is 0. So you're going to have, when you put 0 here, obviously you're going to get 0 for the first part. Hope you're okay with that. So that's going to give you 8t. Does that make sense to you? Hope it does. On the y-axis, x is 0. So wherever you find x, put 0 there. Minus 2 times 0 will be 0. And therefore you have y is equal to 8t. Okay? So your b part is where your y is equal to 8t and your x is equal to 0. Therefore, we can say that the coordinates of b will be 0 for your x, then 8t. Hope that is fine. So now we have your a being 4t and 0. That is the coordinates of a, 4t, 0. Then the coordinates of b, 0, 8t. The question is just asking us to find the area of the triangle AOB. The area of the triangle AOB, which means that when you start from the x-axis to your origin and you move up, what is your area of a triangle? But we do know that when you have, let's say this is your Cartesian plane, okay, your x and y axis, or x and y axis. Clearly, we are looking at a situation where our line is cutting somewhere on the y and cutting somewhere on the x. Now, what kind of triangle do you find here? Guys, look at this. What kind of triangle is this? It's a straight right angle triangle. Straight right angle triangle, okay? Perpendicular because of the coordinates, the axis. So we can just use the ordinary half base times height to find the area of the triangle. Half of the base, then times the height. So the base is just going to be the space between your origin and your x-axis. Do you see that? The distance, the amount of space on your x-axis will be your base. Then your height will be the amount of space when you go on the y-axis. And we know that for the x-axis, it is 4t, which means that we go 4t into our x part, and we go 8t into our y part. Hope it makes sense there. So what is the area of triangle AOB? Okay, so area of, or let's say this is a triangle, okay? AOB, we are going to have our half times our base times our height. What do we get? Half times our base. Our base is what? 4t, okay? Then what is our height? 8t. So what do we get? What happens there? We are going to have, clearly, 2t times 8t. And that's going to give you 16t squared. Okay. So that's the area of the triangle AOB. Hope that is clear. So we are done with the I part of the problem. All right, so I've got a couple of facts here. All right, that's what the second part is asking of. Look at it. I'll just come back to it a couple of in just a sec. Let me just read it from what the question is asking. We are saying that the line through P, and that's what I've written. The line through P, which, and we know P to be 3t, 2t. Okay, so the line through P, which is perpendicular to AB, intersects the x-axis at C. So the line that goes through the point 3t, 2t, and is perpendicular to AB, intersects the x-axis at C. The question is that we want to show that the midpoint of PC lies on the line y equal to x. Clear? Okay, so let's see how we go about that. It's simple. We have a line. This line goes to the point P and is perpendicular to AB. Okay, it's perpendicular to AB. And we are saying that it also intersects the x-axis at C. Let's find the midpoint of, we want to show that the midpoint of PC lies on the line y is equal to x. Clearly, it therefore means that we need to find what C is. Because if you are saying the midpoint of PC, it means when you have the point P and the point C, the middle point, hence you need to find what C is. Now the connection that we are seeing for C, it's saying that the perpendicular that goes to the point P, okay, to AB intersects the x-axis at C. So we can only find C if we know that equation of the perpendicular. Hope you understand that. Because it is that perpendicular that goes to intersect the x-axis. Guys, hope you're following. So if you don't know the equation of the perpendicular, how then do you find the point at which it intersects the x-axis? You get the reasoning? I'm sure you do. So we need to find the equation of the perpendicular. And the question is saying that that perpendicular goes through the point P and it hits AB. It hits the AB at 90 degrees. Okay, from the previous part, the first I part, we know that the gradient of AB was what? Let's call this like M. Let me make it a big M. So anywhere you see M, like convention, coordinate geometry means the gradient. So the gradient of AB is what? -2. So you have AB, and this perpendicular hits AB. This perpendicular comes and hits AB at 90 degrees. And you know the rules. Anytime you have two lines that are perpendicular, one is the negative reciprocal of the other. What it simply means is that take the gradient of the first one, turn it upside down, and put a negative to it. That will give you the gradient of that perpendicular. Hope you're okay. So if the gradient of AB, okay, is -2, then MP, I use MP to mean the gradient of the perpendicular, will be the negative reciprocal of AB. All right, so that is going to give you minus. When you turn -2 upside down, you're going to get -1/2, okay? So your gradient MP will be what? 1/2. Guys, hope you're okay. Hope you're okay. Yeah, so that is simple. This line that is perpendicular to AB has a gradient of half. So what is the equation of that perpendicular? 1-point formula. Remember, anytime you want an equation of a line, look out for just 1 point and the gradient, which we have found. We found the gradient to be half, and we know that the perpendicular goes through the point P, 3T, 2T. Okay, so once that we know that, we just pick the 1-point formula and use it to find the equation. All right, so we go y minus y1, and our y1 will be 2T, okay, equal to m half into brackets x minus x1. That is 3T. All right, so let's try and resolve this nicely. Well, what are we going to get? 2y minus 4t, okay, equal to x minus 3t. All right, so we are going to have 2y is equal to x minus 3t plus 4t, because that one's going to go there. So we're going to get what? X plus t. Guys, hope you understand that. So the equation of the perpendicular is 2y is equal to x plus t. You can also choose to even leave it in the general form, y is equal to mx plus c. That is also okay. Said that can give you y is equal to x over 2 plus t over 2. If you want to leave it that way, that's fine. Hope you're clear. So the equation of the perpendicular that goes to the point P and hits AB is y is equal to x over 2 plus t over 2. All right. So now that we know that, we are saying that this equation of perpendicular, the question says that it intersects the x-axis at C. You have y is equal to x over 2 plus t over 2, and we are saying that this equation intersects the x-axis at C. That's what the problem is saying. All right. So if it intersects the x-axis at C, what do? We have to go and find that point of intersection. And on the x-axis, it is obvious from our prior knowledge that y is equal to 0 on the x-axis. So how do we find that? Y is equal to 0. We take this and put 0 wherever we find y. Hence, we are going to have x over 2 plus t over 2 is equal to 0. Are we okay? Hope we're okay. So you're going to get x over 2 is equal to minus t over 2. Hence, your x equal to minus t. X equal to minus t. All right. So that's it. Hence, we can say that at C, what are the coordinates? Our x is minus t and our y is 0. That is what we are saying. So we know our P to be 3t, 2t. Clear? Then our c is what? Minus t, 0. Guys, let me just give you a second. Just look at the calculations. Just make sure you have it. Are we okay? So that's how you go about it. Perpendicular, the issues here, MAB, MP, and you have all that. You have the equation that intersects. And when you come to this portion, you have your C value to be minus T0. And here you have your P to be 3T, 2T. Hope you're okay. So we're going to work with these two. 3T, 2T, minus T0. Hope you're okay. Good. Good. So now the question says that we should show that the midpoint of PC lies on the line y is equal to x. How do we go about that? How do we prove that the midpoint of PC lies on the line y is equal to x? How do we show it? Watch. Okay, so we have the essential parts just there. Our c is minus t0 and that. So we are saying that the midpoint of PC. Let's find the midpoint of PC. So we know midpoint. How do we find midpoint? Okay, x1 plus x2 all over 2, y1 plus y2 all over 2. So that's how we find the midpoint, okay? So let's just try and use that PC, the midpoint of PC. What are we going to get for that? Our x's will be added. So 3t minus, like when you're adding, 3t minus t will give you 2t. Hope you're okay. All right, so we're going to get 2t over 2. Then you have y1 plus y2. That is your y1. That's it. That one's also going to give you 2t all over 2. So what do you get? You get t. Guys, I hope you understand that. So the midpoint of PC is tt. Your x value is t. Your y value is t. And the question says that show that when you reach the midpoint of PC, your y is equal to x. And that's what we have here. That's what it means. Show that PC lies on y is equal to x, which means that the connection at the midpoint between the y value and the x value should be such that the y should be equal to x. When you are able to establish that the midpoint of PC is at the point where your y is equal to x, this condition of it lying on the equation y is equal to x is satisfied. And after we worked out the midpoint of PC, we clearly came to the point that it is t. And therefore, our x value at PC is equal to the y value also at PC. Hence, the condition midpoint of PC lying on the equation y is equal to x is satisfied by this. So we can just simply conclude that hence, okay, PC, the midpoint, like just write as a subscript, anyway, anyhow that is convenient for you. Midpoint lies on y is equal to x. Take a second and just look at the calculations here. Hope you're making sense. Yeah, so that is it for summer 2015 question paper 1-1. Now let's look at the second variant question. Question paper 1-2. Now question paper 1-2, question 7. It says, the point C lies on the perpendicular bisector of the line joining the points A, 4, 6, and B, 10, 2. C also lies on the line parallel to AB through 3, 11. I. Find the equation of the perpendicular bisector of AB. II. Calculate the coordinates of C. Okay, so let's look at the second variant, question paper 1-2. Question paper 1-2 in 2015, coordinate geometry for your P1. Question paper 1-2. Now, question 7 there also was the coordinate geometry question in the problem. Now, this is question 7. The point C lies on the perpendicular bisector of the line joining the points A, 4, 6, and B, 10, 2, like you saw earlier. C also lies on the line parallel to AB through 3, 11. So the I, like the question was asking us, is to find the equation of the perpendicular bisector to AB. perpendicular bisector to AB. Guys, so you just need to remember that when we say perpendicular bisector, it means that line that splits it into two, exactly two parts. So you always need to find the midpoint. Just get that. Anytime formula says that perpendicular bisector, to bisect means to divide into two equal portions. You will always have to find the midpoint. So these are some of the indicators that you need to look out for in an exam. Perpendicular bisector. That will be different from where you are told that it is perpendicular. It may be perpendicular to the line, but it will not be the bisector. Okay, so look out for the keyword. Bisector goes with midpoints. Bisector goes with midpoints. So we are being asked to find the perpendicular bisector of that line, perpendicular bisector of AB, the equation. All right, so let's see how we would do that. We are saying that we have a point A, and A is 4, 6, B is 10, 2. Okay, so A is 4, 6, B is 10, 2. And we are saying that we want to find the perpendicular bisector of the equation of the perpendicular bisector. All right, so how do we find the equation of a straight line? We know y is equal to, y minus y1 equal to m to brackets x minus x1, the 1-point formula, which requires that we need to find the gradient and 1 point. The gradient and 1 point. So what is the gradient? All right, so now let's try and find the gradient of AB, okay? So we say grad of AB. Guys, get it. When I say grad of AB, I'm just referring to the gradient of the line of AB, like the point A, point B. What's the gradient of the line that goes through those 2 points? So we know the gradient, y2 minus y1 all over x2 minus x1. It's pretty simple. All right, so for AB, y2 minus y1, that would be 2 minus 6, okay? So 2 minus 6. Are we all clear with that? All over x2 minus x1. So 10 minus 4. Okay? Now remember, you could just go anyway. It could either be 6 minus 2 all over 4 minus 10. Whichever form that you choose to represent as your A and your B, it should be easier for you to work that out. Okay, so what do we get here? This is going to give us 2 minus 6 is going to give you minus 4. 10 minus 4 is going to give you 6. And what do we get from that? Minus 4 over 6 is going to give us minus 2 over 3. Are we okay with that? Are we okay? All right, so this is the gradient of AB. This is the gradient of AB. So we know that if two lines are perpendicular, the gradient of one is the negative reciprocal of the other. So if the perpendicular bisector, we want to find the gradient of the perpendicular bisector to AB, and we now know the gradient of AB, we will just take the negative reciprocal of that gradient. That will give us the gradient of the perpendicular bisector. Are we okay? Because remember, finding the gradient of the bisector is crucial in trying to establish the equation of the perpendicular bisector too. Okay. So the gradient, I'll call it gradient of BS, okay? That is a label I choose. You could use any gradient of the perpendicular bisector. So we are going to take the negative reciprocal of that. The negative reciprocal of that. What do you get? That's going to give you the negative, turn it upside down, minus 3 over minus 2, okay? And that's going to give you 3 over 2. Are we okay? That's going to give you 3 over 2. So the gradient of the bisector is 3 over 2. Okay, so now we are done with the gradient. Now we need to find the point, a point for the perpendicular bisector. And remember, bisector, like we've said, means the midpoint. So just find the midpoint of A and B, okay? The midpoint of A and B. Okay, so let's find midpoint of A and B, MD. So midpoint of AB. What is midpoint of AB? We know that already, y1 plus x2 all over 2, y1 plus y2 all over 2. All right. So 4 plus 10, okay? What is 4 plus 10? That's going to give you 14 over 2. That will be for the x part. Then 6 plus 2 will give you 8 all over 2. So what do we get for the midpoint? We're going to have 7, 4. Guys, I hope you are clear. Hope you are clear. So now we have the gradient of the perpendicular bisector. We also have a point, that is the midpoint, which is 7, 4. So how do we find the equation of the perpendicular bisector? 1-point formula. We've got all the components covered. All right, so let's fit it in. Y minus y1, which is our 4, will be equal to m 3 over 2 to brackets x minus x1. X minus, what is our x1? 7. Okay, so we can just run the 2 through it and just make it simple. You're going to have 2y minus 8 equals to 3, x minus 7. Are we making sense? So we can just simplify this. 2y is equal to, okay, 3x minus, what is 3 times 7? 21, right? Then plus 8. Okay, so our 2y is going to give us 3x minus 21 plus 8 will give you minus 13, right? Minus 13, minus 13. So this is the equation of the perpendicular bisector to the point AB. That is the I part. Hope you are clear. Okay, so that's for the I part. We are done with it. The I says that we should calculate the coordinate of C. Let's find the coordinates of C. That is the I, as was just shown you. We should find the coordinates of C. How do you find the coordinates of C? Now, let's see what we've gathered so far. We know the point A, B, that was given in the problem, obviously, and we've been able to find the equation of the perpendicular bisector. Okay, and that is 2y is equal to 3x minus 13. I hope you're okay with that. Good. So now we are being told that this point C lies on the perpendicular bisector. Okay, so point C is here, which means that the coordinates of C that we are looking for should satisfy this equation. Do you get that? Now let me just add this. In examination, anytime there is an unknown point that you are looking for, there is a point that you are being asked to find by the question, and you are told that that point falls on an equation of a line. Guys, get this. There is something about that problem that is going to lead you to a simultaneous equation. Because the only way that you can prove that a point lies on an equation of a line is for you to verify by slotting it in. And realize that there are two variables, x and y. So for you to find x and y, you would obviously need something like a simultaneous equation. Because if you don't have another equation to add up to this, or another equation to compare with this, there is absolutely no way that you'll be able to find x and y. Those are two variables. And basic rules of equation says that the number of variables determine the number of equations you need. So you've got two variables, you need two equations. So now that I want to find a point C, and we are saying that point C lies on this, then probably you need to set up another equation, work them simultaneously, and find out the points x and y. Are we okay with that? Okay, so that's just it. Let's just go back a bit. So the question is saying, the facts of the question says that point C lies on the perpendicular bisector, and we've been able to find the equation of the perpendicular bisector. No qualms or problems about that. Okay, so now it goes on to tell us that the point C, this point C, also lies on the line that is parallel to AB through 311. So this line that we are talking about, this other line where C can be found, okay, that line is parallel to AB. Hope you're okay. That line is parallel to AB. And we are saying that it also goes through the point 311. So what do we do? Remember that when we worked out the gradient of AB, grad AB, okay, we got, what was it? We got minus 2 over 3, right? Minus 2 over 3, that's what we got. 2 minus 6, 4, 10 minus 4, 6, so 4 by 6 minus 2 over 3. You remember? That's what we got for the gradient. So if this is the gradient of AB, and we are saying that there's another line that is parallel to the line AB. We know the concept of parallel lines, that if two lines are parallel, their gradients are the same. So this parallel line, let's call it PL, okay? Let's call it P, this line that is parallel. So let's just call it LP. That's my label, LP. So LP is that parallel line we are speaking about, that line that is parallel to AB. Okay, so LP's gradient, right? So LP grad will also be minus 2 over 3. Agreed? Because this line LP is parallel to the line AB, and therefore they will share a common gradient. Now the question is saying that it also goes through this line, goes through the point 311. So what do? Let's find the equation of the parallel line. With that equation of the parallel line, so equation LP, okay? That is the equation of that line that is parallel here, LP, will be y minus y1, y minus, remember this time the coordinates that we are using to find this will be the 3 and 11. Because this is the coordinate that satisfies that equation of the LP. Are you clear? Good. So y minus y1, 11, equal to minus 2 over 3, x minus x1, x minus 3. Is that clear? Okay, so now let's try and simplify this and find the equation of it. So what are we going to get? We are going to have 3 y minus 11 equal to minus 2x, then you have minus 3 here. So let's try and expand and simplify. This is going to give you 3y minus 33 equal to minus 2x plus 6. Okay? So what do we get there? Okay, so let's see what happens. We're going to have 3y plus 2x equal to, then we're going to have 33 plus 6, right? So this is going to give you 3y plus 2x equal to 39. Guys, hope you're okay. So this is the equation of the parallel line. This is the equation of that line, LP, that is parallel to AB. And we are saying that C is also on this point. So the coordinate C falls on this line, this equation, and it falls on that equation too. Guys, you see, it falls on this equation and falls on that equation. It is on the equation 3y plus 2x equal to 39. That's the point C. And the same point C, it is also on the perpendicular 2y is equal to 3x minus 13. So the question is that how do we find C? The answer is obvious, right? It is going to be the point of intersection of this line and that line. So we need to solve these two equations simultaneously. Then we find the coordinates of C. Let's do that. Okay, so putting the two together, these are the equations that we need to resolve. 3y plus 2x equal to 39, 2y minus 3x equal to minus 13. Now, if you were to apply what you know about simultaneous equations to solve this problem, your values is going to be, your x would be 7 and your y will be 9. Yes, so your x will be 7 and your y will be 9. Or 9 or 7, depending on how you work that out. So the coordinates of that will be 7 and 9. Okay? 7 and 9. 7 and 9. Yes, I think your x will be 9 and your y will be 7. Okay. So that's how it's supposed to go. Okay? So 9 and 7 and y will be 7. These are the values that you're going to get. So we can therefore say that the coordinate of C will be that. You just choose those values and you are done with the problem. Are we okay? Now this is the third variant question. Question paper 1-3. Now question 7 has this to say. The point A has coordinates P1, and the point B has coordinates 9, 3p plus 1, where p is a constant. I, for the case where the distance AB is 13 units, find the possible values of p. II, for the case in which the line with equation 2x plus 3y is equal to 9 is perpendicular to AB, find the value of p. Okay, so we look at the last variant, question paper 1-3, and again question 7 of that, as the question was also shown on your screen. So we've got coordinates P1. Let's just try and take the details down, then we'll see how to deal with that. So we've got the point A. Point A, we are told, has P and 1, and the point B has coordinates 9 and what? 3p plus 1. Okay, where the p is a constant. Okay, so we are saying that for the case where the distance AB is 13 units, find the possible value of that. So this is just a question of a distance formula. Okay, we are saying that if the distance is 13, what do you do? The distance is 13. What do you do? Find the possible values of p. Okay, so we know the distance formula already. Okay, we can use the distance formula. And we know that the distance will be equal to the root, okay, of y2 minus y1 all squared plus x2 minus x1 all squared. That's what the distance formula actually means, where d is the distance. So if the distance is 13 units, we can just slot the 13 units in there, okay? So we're going to have 13 root, okay? So 3p plus 1 minus 1 is going to give you 3p. Hope you're okay. That's what the problem says. And plus, then it's going to give you 9 minus p all squared. Okay? So 9 minus p all squared. Okay, so this is going to give you squared. And that's going to be 13. Okay. What do? You just square, obviously, to take away the root. And you're going to get 169, which is 13 squared is equal to 3p all squared plus 9 minus p all squared. Okay, so this is a bit of algebra. Simplify a bit of algebra. You're going to get 169 equal to 9p squared plus 81 minus 18p plus p squared. So obviously, when you look at it, it is turning out to be a quadratic equation, you see, because you have a square term, then another single letter coming, then the constant, and you see how you have to work it out. So that's going to give you a quadratic. Now, if you resolve this quadratic, your possible p-values should be 4 or minus 11 over 4. Hope you're okay. So that's just it. The use of the distance formula, then the rest is just algebra for you to be able to manipulate. I'm not sure that's much of a problem. So the II part says that in a case in which the line with the equation 2x plus 3y is equal to 9, okay, is perpendicular to AB, and that is AB, find the value of P. So in the case where this line is perpendicular to that, we want to find the value of P. When lines are perpendicular, you know what connects them. In coordinate geometry, we are saying that, well, we know that the gradient of one is the negative reciprocal of the other. Or what we are saying is that the product of the two gradients, you take this one's gradient, multiply by that one's gradient, it has to give you negative 1. So if two lines are perpendicular, they are connected in their gradients to the extent that the product of the two gradients should give you negative 1. So if we want to connect the line 2x plus 3y is equal to 9 to AB, it's obvious. Let's find the gradient of that line. Let's compare it with the gradient of AB, and we are saying that the product should give us negative 1, or the negative reciprocal of 1. One of the gradients should be equal to negative 1. Okay. The product should be negative 1. All right, let's use that. Okay, so now let's take this one, okay? 2x plus 3y equal to 9. We want to find the gradient. So we put in the form y is equal to mx plus c, because remember, that is the only way that we can deduce the gradient there. All right, so this is going to give you 3y is equal to minus 2x plus 9. We divide here by 3. And our y is going to give us minus 2 over 3x plus 9 over 3 is going to give us 3. Okay, so the gradient of this equation, okay, is minus 2 over 3. That's the gradient of this line. Okay, now let's try and find the gradient of AB too. The gradient of AB, what would it be? So grad AB, okay, the gradient of AB. Remember, the grad is my choosing. You can use a different thing. So the gradient of AB will be y2 minus y1 all over x2 minus x1. Simplicita. Okay, so let's look at that. So 3p plus 1 minus 1 is going to give us 3p, right? Then 9 minus p. 9 minus p. Okay, so this is the gradient of AB. Okay, and that is the gradient of the line there. We are saying we should find the value of p. So what it simply means that when we take this and multiply by that, it has to give us negative 1. Or one of them could be a negative reciprocal of the other. Okay, so let's take the minus 2 over 3 and pick its negative reciprocal. What would it be? If you were to turn minus 2 over 3 upside down and negate it, you're going to have 3 over 2. Guys, you get that? You're going to have 3 over 2. Minus 2 over 3. You take its negative reciprocal. So the 3 goes up, the 2 comes down. You have 3 over 2. The negative still pending. Then now you push a negative in there. What are you going to get? You're going to get 3 over 2. So a negative reciprocal of minus 2 over 3 should be equal to this. Hence, we can say that our 3p all over 9 minus p should give us 3 over 2. Are we okay with that? Yeah, sure we are. Okay, so now let's cross multiply. That's going to give us 6p is equal to 3 times that. You're going to get 27 minus 3p. Okay, and that's going to give us 9p equals to 27. And our p should give us 3. Pretty simple, right? So that is how we work with that, and that brings us to the end of the last variant on coordinate geometry in 2015.